A ball is dropped from the building and simultaneously another ball is projected vertically upwards with some velocity. Describe the change in relative velocities of the balls as a function of time. Look at this. This is a tower. A ball is dropped and at the same time one ball is thrown vertically upwards. So its initial velocity is 0, but it has some initial velocity u. After some time t, the ball is somewhere here and this ball is somewhere here. Its velocity is say v1, its velocity is say v2. He is asking us to find the change in relative velocities. First of all, let us find the relative velocity. Relative velocity means this velocity minus its velocity, v1 minus v2. v1 is downward direction, v2 is in the upward direction. If I take this as positive, this must be negative. That's why it becomes a minus of minus. So the relative velocity is equal to how much? v1 plus v2. But what is v1? For the first case, v1 is equal to u plus at is equal to 0 plus a means g into t. So v1 equal to gt. For the second ball, v is equal to u plus 8 again. But here final velocity I took as a v2. v2 is equal to u. It has some value u. Here means here minus g as the ball is moving upwards. Velocity is taken upwards, g is downwards. So if v is positive, g must be negative. That's it is minus g into t. This is our v2. If I substitute this v1 and v2 values here, I get the relative velocity is equal to zt plus u minus zt, where zt gets cancelled, and v1 plus v2 is our relative velocity is nothing but our u, where this u is our initial velocity with which the second body is thrown, so which is fixed value, means the relative velocity is constant. As the relative velocity is constant, what is the change in relative velocity? As it is constant, there is no change. That's why the change in relative velocity is 0.